There are many proofs, and some of them quite complicated, that root 2 is irrational. I'm going to start by saying that we can have the root of some integer n is equal to a fraction a over b, where a and b are whole numbers which do not have a common factor. We can't cancel a and b. We say that that's in its lowest form. A and b don't have any factors in common. There's nothing we can cancel the top by and the bottom by in that fraction. And that means if we look at n must be the square of a over b squared. So it's a squared over b squared. And that too must be in its lowest form, because if we can't cancel anything in a with b, we can't cancel anything in a squared with b squared, because a squared just contains all the same factors as a, but twice, and b squared contains all the same factors that b does, but twice. So a squared over b squared is in its lowest form. But the lowest form of a number n is equal to n over 1. And since a rational has only one lowest form, that means that b squared equals 1 and that a squared equals n. b squared equals 1, a squared equals n, and in particular root n is equal to a, which is an integer. And that means that if we can express the square root of any integer as a fraction, then the integer must be a square number. 2 is not equal to any number squared. Therefore, root 2 is not equal to any whole number a over any whole number b. And that's the end of the proof. Simple as that.